Welcome you all to the past paper discussion special relating to the linear programming. Here we are going to discuss the answer for HNDA 2020 past paper. In 2020, the examiner has focused on the theoretical aspect in the first part of the question. Here the examiner asks the student to explain three theoretical concepts, that is objective function, feasible region and constraints. But here the examiner expects from you to write a brief explanation. Since it is 3 marks, no need to elaborate much. So you can write the objective function as the function we wish to optimize, that is either maximize or minimize. For constraints, those are restrictions or limitations imposed on decision variables. For feasible region, it is the region containing points satisfying all of the constraints. Choosing any point in this area would result in a valid solution for the objective function. Now let's look at part 2 of the question. A diet, which means a meal, is contain at least 20 ounces of protein, 15 ounces of carbohydrate, and there are 3 foods, X, Y and Z, and each costing 20 rupees, 10 rupees and 15. And each unit of X contain 2 ounces of protein and 5 ounces of carbohydrate. Each unit of Y contain 3 ounces of protein and 2 ounces of carbohydrate. And each unit of Z contain 4 ounces of protein and 2 ounces of carbohydrate. The question asks how many units of each food should the diet contain so as to minimize the cost. Then the examiner asks you to formulate the linear programming model for 5 marks. So you know, in the linear programming model, there are 5 steps. For each step, you will get 1 mark each. In the exam, it's easy to understand if we are putting the whole statement into a table like this. Develop the linear programming model. The first step is defining variables. Let X equals number of X foods has to take for the diet, Y equals number of Y foods has to take for the diet, and Z equals number of Z foods has to take for the diet. Our objective function is to minimize the cost. Therefore, objective function of cost minimization can be derived as 20x plus 10y plus 15z. Now let's look at the constraint and non-negativity constraints. Even though we can take X, Y and Z, there is a limitation of protein and carbohydrate intake. Therefore, it says the protein intake should be a combination of 2x plus 3y and 4z, and it should not be exceed 20 ounces. And the carbohydrate intake is limited for 15 ounces and it is a combination of 5x plus 2y and zx. Then the non-negativity constraint is x, y, z should be greater than or equals to 0 because there is no negative food in intake, which means either we are going to eat the food, if not, we are not going to take it. There is no negative figure involved in this. When you get a problem in linear programming for your exam, first thing is you have to identify the linear programming problem. To identify the linear programming problem, there are 5-step model is involved. First one, you have to identify the problem. Secondly, you have to collect the data. Thirdly, you have to formulate the linear programming model. Fourthly, you have to find the solution, either graphical or simplex method. And finally, you have to do the interpretation. So let's move on to part 2 of the question. So in this question, we are going to see a company naming Sujit and Company, which manufactures two brands of products, namely P and Q. Both these models have undergo operations on three machines: lathe, milling, as well as grinding. Each unit of P gives profit of 45 and requires 2 hours on lathe, 3 hours on milling, and 1 hour on grinding. Each unit of Q give a profit of 70 rupees and requires 5, 5 and 4 hours on lathe, milling and grinding. So here when you are going through this question, you can see they are focusing on the profit. And P's profit is 45, whereas Q's profit is 70. So you can see three machines: lathe, milling and grinding. So we have to see and we have to focus whether there are any restrictions on these machines. Here it says, due to prior commitment, the use of lathe hours restricted to maximum 70 hours in a week. The operator to operate milling machines are hired 90 hours per week. Due to scarce availability of skilled manpower for grinding machines, the grinding hours are limited to 100 hours per week. So you can see each machine have a restriction. So you can't go beyond these restrictions, and this will be a constraint under the linear programming model. And finally, it says the market limits week sales product Q to 10 units. So when there is a limit, they cannot go below this limit. Therefore, the product Q should be more than 10 units. Then let's see what is the question is all about. The question is all about finding the optimum product mix using graphical model. So you know, in a linear programming model, there are two types. So first one, we can find the solution by using graphical model, as well as in the second type, we are focusing on the simplex model. Since this question is mainly focusing on two products, we can easily go for graphical model, which is required by the examiner. In an essay type of question, it is easy to collect the data and put it into a table form, because you will easily go through the data without wasting much time when there is an essay or a para. So in this table, you can clearly visible the profit of each product as well as the constraints, which means the hours limitations of each lathe, milling and grinding machines, as well as the maximum sales restrictions of Q in the market. So, you know the 5-step model of the linear programming model. So, when we are going to formulate the linear programming model, the first one is we have to define the variables. So here there are two products, which is P and Q. For the easiness, I am going to use simple P and Q to denote these variables, which means let's assume that simple P will reflect number of P products which has to manufacture, as well as simple Q to represent number of Q products has to manufacture. And now let's focusing on the objective function. So in the question, it's clearly mentioned the objective is to maximize the profit. Therefore, we have to maximize the profit, which is denoted by Z. with the combination of P's profit into number of units, which is 45P, as well as Q's profit into its quantity. Therefore, total will give as 70Q. Now let's move on to the constraints. And here I'm going to take the first constraint as the lathe hours. So in this question, each P is needed 3 hours and each Q needed 5 hours. Therefore, as a combination of these two, we can get a formula as 2P plus 5Q. And this should be lesser than or equal to 70. Why? There is a restriction of the lathe hours. So let's move on to the milling hours. Each unit of P need 3 hours and each unit of Q need 5 hours of milling. So we can write the formula as 3P plus 5Q. Since there is a restriction of hours, this should not be exceed. Therefore, it is less than or equal to 45. And the third one is grinding. So each unit of P need 1 hour and each unit of Q need 4 hours. And we can derive it as P plus 4Q, but it should not be exceed 100. Why? There's a restriction which is clearly mentioned in the question. And finally, we are going for the maximum sales constraint. So it says Q should not be less than 10. Why? There is a market constraint. After going through this constraint, we have to go for the non-negativity constraint. So you can see this is a question of manufacturing. So in the manufacturing question, there should be positive quantities and we have to ignore the negative quantities. Therefore, each P and Q should be greater than or equal to 0. See how we are going to find the coordinates for the graph. To find the coordinates, we have to remove these inequalities. Inequalities are reflected with this less than sign. So we have to remove them and we have to develop equations with equal sign. Then only we can find two coordinates for x-axis and y-axis in the graph. Accordingly, the equation in the yellow color reflect the equations which ignores the inequalities. So based on these equations, we can find the coordinates of the graph as follows. So sometimes you may wonder how we have developed these values for P and Q. So let's move forward and find how we have developed these values for P and Q. Let's find the coordinates of the graph. So here I am firstly take the first two equations, which is lathe hours as well as the milling hours. So let's say the first equation as the lathe hours. So I'm going to find the coordinates by subject to equation 1. So here first I'm going to assume the value of P as 0. So I'm going to substitute 0 for P. Then ultimately I have derived the value of Q as 14. Then in the next one I'm going to assume the value of Q as 0. So then I'm going to substitute 0 for this Q value. Then I have derived the P value as 35. Let's do the same for the equation number 2, which is our milling hours. So in that one, first I'm going to take the P as 0. Then when I substitute the value 0 for P, I have derived the Q as 18. Then when I assume the Q as 0, I'm going to substitute 0 for this Q of the equation. Then the answer is P is 30. So now let's do the same for the next two equations as well. Find the coordinates for the grinding hours. So in this one, as same as previously, we are going to find the value of P as well as Q. First, we will assume the value of Q as 0. So here, when we substitute P as 0, ultimately we will get the answer of Q, which is 25. Then I am going to substitute the value of Q as 0. Then the ultimate answer of P is 100. Now, based on these coordinates, we are going to use the graphical solution to find the answer for the linear programming problem. Now, based on the constraints, let's develop the graphical solution. So, in the graph, you can see the lathe hours in black straight line and milling hours in blue straight line, grinding hours in red straight line, and finally the market demand restriction with green straight line. So you can see all the constraints are less than or equals. Therefore, to satisfy all the four constraints, I have identified the feasible region as A, B, C, and D. So now these 4 points are also known as the corner points. So the next step is, through this corner point, we have to identify what is the highest profit and which product we should produce. When we are going to find the values for corner points, it's easy to find the values for A because it is 0 for P and 10 for Q. Whereas for D, it is 0 for Q and 30 for D. However, when we are going to find B and C, we have to solve the simultaneous equations. To find point B, we have to solve equation number 1, which is lathe hours, and equation number 4, which is the market demand. So it's easy. Why? We can easily substitute Q equals 10 to the equation number 1. So by substituting the value, we are getting P as 10. So let's see how we are going to find point C. To find the point C, we have to solve the equation number 1 of lathe hours and equation number 2 of milling hours. So you can see 5Q is common for both equations. Therefore, from the highest figure, we are going to deduct the lowest figure, which is from equation 2, we are going to deduct equation number 1. So accordingly, we are getting P as 20. So now what we are going to do, we are going to substitute P equals 20 to equation number 1. So ultimately, we are getting Q as 6. So what we are going to do is, for each corner point, we are going to find the profit figure. So the profit figure is Z equal 45P plus 70Q. So for each coordinate of P, we have to multiply it with 45, which is the profit figure of P, and for each corner point of Q, we have to multiply it with 70. Why? Because it is the profit figure for Q. So by substituting these figures for each corner point, we are going to derive the profits. So what we have come up is the highest profit figure. According to the question, the highest profit figure is 1350. Let's interpret the result. So we can conclude that to gain the maximum profit of rupees 1350, the company should manufacture at least 30 units of product P.